As we have built up a concept about electric charges, their types, and charging by induction earlier, what would be the next? Namaskar, Jai Guru. I am Ritesh Kumar Pathak, lecturer, intermediate section of Yogoda Satsanga Mahavidyalaya. I will introduce you with the basic properties of electric charges in this lecture. Here, there are three basic properties of electric charges that is given in our syllabus. It is well known fact that there are two types of charges, namely positive and negative, as we have seen in the earlier lectures, and their effects tends to cancel each other, and that is why a material is said to be a neutral substance. If the size of charged bodies are very small as compared to the distance between them, we treat them as point charges. Just like in the case of point objects, if the size of an object is very smaller to the distance traveled by that, it is termed as point object. Similar case happens here. Apart from it, there are some other properties of electric charges, and these three properties, additive nature of charges, conservation of charges, and quantization of charges, that we have to study here. So let's start with first one, additive nature of charges or additivity of charges. It states that the total charge on a body is the algebraic sum of all the charges located anywhere inside the body. If a body is charged and at one place of that body or material, if there is plus 2q charge and at the other side there is plus q charge only, then the total charge will be calculated as plus 3q, as I have stated in the given example. On the other hand, if a body contains plus 2q and minus q charge, then the algebraic sum will obviously be plus q only, and that would be the total charge present inside a particular body. So in general way, we can say that if a system contains n charges like q1, q2, q3 up to the qn, then the total charge of the system is q1 plus q2 plus q3 plus up to qn. Now, moving towards the conservation of electric charges, it states that within an isolated system, that means a system which cannot gain any charge or cannot remove any charge from it, consisting of many charged bodies, due to interaction among the bodies, charges may get redistributed, but it is found that the total charge of the isolated system is always conserved. It is not possible to create or destroy net charge carried by an isolated system, because we know a body can be charged by gaining some electrons or by losing some electrons. If a material or body gains some electron, then that will be negatively charged, or if it loses some electron, there will be positive charges on that material or body. So if there is an isolated system, the total charge will remain constant, and this shows the conservation of electric charges. Now, the next property is quantization of charge, and this one is very important. Since we all know the electron is an elementary charge which cannot be divided into further smaller parts, so we can conclude that total charge on a body is integral multiple of the charge on an elementary charge, which has the value 1.602192 into 10 to the power minus 19 coulomb. So, for explanation, if we take Q charge that appears on a body and n is positive or negative integral number, then mathematical formation of this rule, this law, quantization of charge, will be given as Q equals to plus minus NE, where small n is an integer, either positive or negative, whereas small e is the basic unit of charge, whose value I explained earlier. It simply means that the possible charge on a body may be E, 2E, 3E, means 2 times of the basic unit of charge, 3 times the basic unit of charge, but the fraction times the basic unit of charge is not possible, and hence I have written here 0.5e, 0.7e, 2.5e are not allowed. That means that whenever there is a transfer of charge, the electron, the transfer of charge particle, will be in complete form. There will not be any fractional part that gets transferred from one body to another. So this is the meaning of quantization of charge. For the better understanding, let us take some example. So here the example says a conductor has a positive charge of 11.2 into 10 to the power minus 19 coulomb. Here coulomb is the unit of charge. Then how many electrons are in excess or short than normal state? So from question, it is very clear that the conductor has positive charge. That means the positive charge implies that there is a shortage or lack of electrons. Now we will proceed to the solution. The given data here, the charge Q equals to 11.2 into 10 to the power minus 19 coulomb, and the basic unit of charge E that has the value 1.6 into 10 to the power minus 19 coulomb. We all know the relation Q equals to NE from the rule of quantization of charge. So we may write N equals to Q upon E. When we put the values of Q and E in the specific equation, we get the number N equals to 7. As the conductor has a positive charge, hence there is a shortage of 7 electrons. Now move on to the next example. Is a charge of 5.8 into 10 to the power minus 18 coulomb possible? The solution is given here. Q equals to 5.8 into 10 to the power minus 18 coulomb, and E has the value 1.6 into 10 to the power minus 19 coulomb. Again, from the quantization relation Q equals to NE, we get N equals to 36.25, which is of course is a fractional number. So as the value of N is not an integer, therefore we can conclude the value of charge is not possible. I hope you have got an idea about quantization, additive property of charge and conservation of charge in this lecture. If still you have any doubt, you can leave a comment for your related doubts. Thank you. Jai Guru.